For section 8.3, we're going to talk about expected value. Expected value is the long-run average outcome of an experiment. So, for example, if you played the lottery every single day, say you played the lottery every day for 1,000 days, you would take all of your winnings and you divide by 1,000, and that number would be your expected value. That would be how much on average you expect to win during your whole time playing. So there is a formula for expected value, and it is the probability of an event times the payoff of that event plus the probability of another event times the payoff of that event. And you could go on and on if there were more events. So we will try this. We'll try it with example 1, which is a lottery example. So it says, in a state lottery, a single digit is drawn from each of 4 containers. Each container has 10 balls, numbered 0 through 9. To play, you choose a 4-digit number and pay $1. If your number's drawn, you win 5,000. If your number's not drawn, you lose your dollar. What is the expected value? When I write expected value, I'm going to write EV. And I need to think about what could happen if you play the lottery. 2 things. You could win or lose. So I'm going to say probability of losing times the payoff of losing plus the probability of winning times the payoff of winning. So those are my 2 events, lose and win. So my expected value is going to be whatever I get when I find all these numbers, multiply, multiply, add them up. So the probability of losing here, if there are 10 balls in each of 4 containers, the total tickets, or which would be the total possible numbers, would be 10 times 10 times 10 times 10, which is 10,000. And I know that because to figure out how many of something there are, you just take the total possible of each thing and multiply them together. So the probability of losing, if there's 10,000 tickets, all but 1 ticket is a loser. So 9,999 losers over 10,000 total. That's the probability of losing. Now, if you lose, what is your payoff? You would be down $1. Now winning. There is 1 winning ticket over 10,000 tickets, and the payoff of winning, if you win, you get 5,000, but it did cost you $1 to play. So I would say in the end, it would be $4,999 because of that $1 to play the game. So if you multiply this and add them together, your expected value ends up being negative 50 cents. So that would be if you played every day of your whole life and averaged all of your negative 1s and your 4,999s whenever you won it, it would average out to be 50 cents a day.